Hey, chemistry students. So today we are learning about half-life, and I have a really fun activity for you to do today that not only is self-grading, so you'll know if you're right or not, but also when you're done, you're going to get a really cool picture at the end. So you're going to be able to tell whether or not you're doing everything correctly. But since we are just starting this concept, I wanted to show you guys how to complete this activity and also do a couple of examples with you. I'm going to do number 1 and number 3 and then show you what it should look like when you're correct. Okay, so we're doing half-life. So what I have is I have a Google Doc here that I'm just going to put a table in. You could also use another Excel sheet, it doesn't matter, but I just have a blank Google Doc and I'm going to insert a table, and I'm going to do 2 because I know I'm going to need one for my time and one for my amount. Remember, because we're doing half-life and we're going to do a T-chart. Now, of course, you can do this on a piece of paper because this is self-grading, so I'll know if you're correct just by you having the correct picture. All right, so question 1 says the half-life of bismuth 198 is 10.3 minutes. How much time has elapsed if only 12.5% of the radioactive sample remains? Report the answer to 1 decimal place. All right, so we're going to start, we always start with our time as 0 because we always start with our initial amount. And I wanted to do number 1 with you guys because the example that we did in our lesson notes was with grams. And so I wanted to show you one with percentage. Now, percentage is pretty easy because all we have to do is start with 100%. And it's going to be the same process all the way down. We're just going to do, we're going to divide it by 2, okay? So our half-life is 10.3 minutes. So our first event is 10.3. And our amount, because it's a half-life, is going to go from 100% to 50%. Oh, oops. That's all right. 50%. Now we need another half-life because remember our question wants to know how much time has elapsed if 12.5% remains. So we're just going to keep doing this process until we get to 12.5%. So our half-life is 10.3. So 10.3 plus 10.3 is 20.6. And then 50% divided by 2 is 25%. Okay? We're still not done. We need another half-life. Remember, we're not doubling here, so we're not going to double 20.6. We're going to add 10.3 because that's the amount of the half-life. So 30.9 and 25 divided by 2 is 12.5%. Okay, and here we're done. So we wanted to know how much time had elapsed after when the sample decayed to 12.5% of its original amount. So it's 30.9. So the answer here is 30.9. Okay. Now you're going to choose your unit. So you want to be careful to choose the correct unit because if you don't choose the right unit, it will not work. But because the half-life was in minutes, our unit is going to be in minutes. And then because that is correct, you're going to see these colored grids pop up on the right-hand side of your Excel sheet. You're going to do this all the way down, and if everything is correct, once you type in your answer, the colors will appear, and then once all problems are correct, you'll see a picture on the page. Okay? So let's go ahead and do one more. I'm going to delete these. We always start with 0, so I'll leave that 0 there. So I'm going to do number 3 with you guys because this one, again, we're dealing with percentages and sometimes that can be tricky. It says, how long would it take a sample of lead 201 to decay by 75% if the half-life of lead 201 is 9.33 hours? Okay, this one is hours, so make sure when we're reporting it, it's going to be in hours. Report your answer to 2 decimal places. Okay, so it wants to know how long it would take to decay by 75%. Okay, so not to 75%, but by 75%. So if you're decaying something by 75%, that means we should have 25% left. So we're basically, just like we did in the last problem, we're looking to see how much time it takes to get to 25%. Okay, so We'll start, of course, with 100%. And our half-life is 9.33 hours. So 9.33 hours, okay? So 100 divided by 2, our first half-life, 50% remains. Now we need to add 9.33, so 18.66 hours have elapsed, and 50 divided by 2 is 25%. Now this is the point we're looking for, because since there's only 25% of the sample left, 75% of the sample has decayed. So that is what we're looking for. So the answer is 18.66 hours. And there we go. So again, it's super easy to check yourself. If the colors don't pop up after you type in your answer, that means something has gone amiss and you need to rework it. But I just wanted to do those examples to show you. You'll be doing a combination of solving for time, solving for the amount that's left over, solving for percentages. So if you have questions or need help, of course, reach out. I will be more than happy to help you. But yeah, when you're done, you'll know it's all good because there will be a very distinctive picture here. I think it's a pretty cute picture, but you'll be able to see it. All right, so that's all for these examples. Good luck. And of course, if you need help, let me know.